Hello and welcome in another episode of PLC ladder logic programming. In this episode, we are trying to describe ladder logic elements like normally open contact, normally closed contacts, and coils. These are the three basic elements in ladder logic. To those who knows about high-level language such as C, C++, or JavaScript, there is a correlation with this ladder logic, how to understand ladder logic with the perspective of the programmer from computer science. The programming such as C, C++, if you know, for you ladder will be much easier than you expect. If you think ladder is something different beyond your understanding, then you are wrong. Ladder is very simple language. It's molded with a graphical representation representing the program with the graphical element. Like the Chinese language, they don't have any identifiable alphabets like English too, or Hindi, or like Bengali. They have like Bengali, Hindi, English, or Arabic. They have their own pre-defined alphabets, and with the arrangement of alphabets you create words, and with the arrangements of words you create the sentence, and that way the language work. But in Chinese language, if you see, there is a symbols with the different strokes of dashes and lines. You create meaning. So it's actually picture that gives meaning. But picture you can understand in different perspective. The picture is a word for them. So combination of picture is a kind of meaningful sentence. So that way ladder is you have to look into ladder as a different perspective. It's not something that you understood in C++ or Java programming. That programming language is different. Ladder logic is a different programming language, but you can correlate them. That's how I will do here. If you know the symbol, this one, I hope if you are trying to learn ladder logic, then you know this symbol, and this one all as well. These two symbols are very popular. Very popular means they are actually a basic element in ladder. This is one element, and then there is another element. It looks like this. It's called coil. I will show you in the program right now. So I have Studio 5000 Logics Designer opened, and in it there is a ladder logic editor where we can edit or create ladder logic program. So this on the left side is called controller organizer, where we can add controller and add inputs, outputs, communication modules. Okay, you don't have to worry about these things. These terminologies you will understand later on, slowly. Everything will be taught in this course. So focus now on only this part where I'm teaching you the ladder element. Now on this section you see a ladder instructions. So each instruction is grouped by a particular group tab. This is a bit tab. So this bit tab operates on bit variable, like Boolean variable. Now the symbol I just shown you are these three. You have one instruction with the 2 parallel stroke, another instruction with 2 parallel stroke, and then in the middle there is one more stroke, little bit slide, and then another instruction with this round bracket on both sides, 2 brackets, as if you see the bracket in your program, something like this. Okay, so that's called actually coil. The name of that instruction is coil. Sorry, this is coil. We will talk about these 2 instructions right now. If you know the relay and switch, for example, SWITCH, switch, electrical, these are the switch, and then what they do, their purpose is to connect the electrical active live wire from one side to another. When you turn one, the electricity flows from one side to other side, either from below to upside or from top to bottom. It completes a circuit, right? Now if you see the push button, it has a different design. So when you press the button, it connects from one terminal to another terminal. It's the same principle, just like switch one, but the main purpose is to connect the wires. By that, let me show you circuit. Okay, so if this is a push button circuit, when push button is pressed, it connects from one terminal to another terminal, just like this animation. When it connects, the battery power goes to the other side and activates the LED or a light or whatever the actuator is. Now purpose of this is to tell you that these 2 elements are opposite in function. So this one is like simple switch, and it has a parameter. It can be a start button. Now the giving the tag is not enough. It has to be defined, like you create a variable with the proper name and definition and scope. So I'm creating a project Shiva, and then main program. Under the main program is this folder, create, and then stop variable, another tag, create, and then motor variable. Unless you have a defined tag, your rung will be incomplete. So now it's no more red. This rung is complete. Now start button is something we imagine that it is linked with the physical electrical switch, like this one. If you have something like let me open another this one. I think red color will be better. So if you have PLC, this is your PLC, and you have input and then you have output. This side is in, this side is out, and your PLC is this one. So when you have a switch and you press that switch, you connect the switch. For example, this is your input that is connected to this input. Then the value of start, that parameter will be 1 if it is connected. But if it is not connected, then the value of start will be 0. So either that can be 0 or 1, and this instruction is nothing but a function. This is a function, and you have a parameter, that is start button. Okay, so it returns a value just like you do in your any other programming language. For example, if I let me open a Paint, and Paint is good for showing such thing. And let's say you have a function, and you create a function like this one is buffer is your function, and then you give start as a parameter, and then you write the program. But this function returns a value. What it returns? It returns the same as the parameter. You close the variable, you close the function, sorry. So buffer is a function which has a parameter, and then parameter is the start here, start variable, and this start is connected to the PLC input. So this section is like a function that has a parameter start, and it returns a value same as start. So if it is start value is 1, it returns 1. If it is 0, it returns 0. Now if it is returning 1, then only the next instruction will be checked. The main philosophy is that if in series there are multiple instructions, if one of them is not returning 1, or one of them is returning 0, then the right side function or call will not be executed. So if it is returning 1, then it will come here and wait for this instruction. It will execute its function. So what is the stop function? Stop function is just opposite of this function. It is something like invert function in digital world, something like this, and then you have return, which is invert of stop. You know what I mean? So it actually, if you pass 1, it pass 0. If you pass 0, it return 1. So whatever you give or pass parameter to this invert function, it returns the opposite. That means that if true is passed, then false will be returned. If false is passed, then true will be returned. So that is the main difference between that two functions. This one and this is left side, this one, and the other one is this one. So this one creating invert of the parameter, whatever the parameter is here. Okay, and here also you have parameter start, here you have stop. Now that's the main difference between those two parameters. Now another thing, if you give start here and again start here, okay, this is the value of this will be different in each. Let me create another rung. Okay, here. So the output of this function will be 1 if it is 1. The start is 1, that means return is 1. But if this is used, this instruction with this stroke in the middle, then this function will return 0 because start is 1. That's how I draw, right? If you pass 1 here, it will return as 0. It will return 0. and then if it is 0, then it will not go on the right side. It will stop executing that ladder from that place only. So I think I am quite confident that you understood between these two functions. Another way to understand between these two, the difference of these two instructions, is to understand it like, the buffer in digital electronics. If you have been in the electronics, electrical or instrumentation engineers, they will understand it quite very easily, or diploma holders who have attended the digital electronics course, they will also understand this logic. This is called invert circuit, and this is buffer. So this circuit is equivalent to this one, and this symbol is equivalent to this one. I draw it again. This one is this, and this one is this. Okay, normally open, many people used to call it normally open, and this one normally closed, but that is not the terminology we should use. In Rockwell, it is called examine if close or on, examine if open or off. So XIO for off, XIC for on. So I think that is on or off. Examine if on, examine if on, examine if off. That is good terminology to understand. But if you are confused, then just correlate with this one. This is this one, and this is this one. And this concept is very good to remember. It's if you give 1, you get 1, you give 0, you get 0. But in this invert circuit, you give 1, you get 0, you give 0, you get 1. So that's the difference. It's totally opposite of these two instructions. Each other, they are totally different. And that's what I am trying to teach you. So for this, I think 17 minutes now, I should stop and make another video for another thing. Thank you, and see you in the next video.